All right, everybody, we're going to be doing notes 5.4. We're going to be talking about dividing polynomials. Okay, so the division algorithm for polynomials. So if you divide a polynomial, p of x, so remember p of x just represents any single polynomial, by a different polynomial, d of x. Remember we use p and d just to differentiate the two different polynomials. Then to get a polynomial q of x, which is the quotient, and a polynomial remainder r of x. Okay, so the result is p of x, so your original polynomial is equal to whatever you divided by, d of x, times the quotient, x of x, plus the remainder of x. If the remainder is 0, then we know d of x and q of x are factors of p of x. Okay, yeah, that sounds really confusing, so let's just talk about it with basic division that we already know. So we'll do like a little example here. All right, so let's do 23 divided by 5. Okay, so we're going to do long division. So remember, inside your house is 23. We're dividing by 5, so 5 is on the outside of your house. Okay, 5 is called your divisor, what I'm dividing by. Perfect. All right, so let's go ahead and remind ourselves how to do long division. So I'm asking myself, okay, so how many times can 5 go into 2? 5 cannot go into 2. So now we move over a place. How many times can 5 go into 23? So we know 5 can go into 23 4 times. Okay, and then remember, once we figure that out, we multiply it back. 4 times 5 gives me 20. Okay, here's where we make a huge mistake. We subtract these from each other. So make sure we put subtract. This is going to come in handy when we start long dividing polynomials, being really vigilant about subtracting everything. So then we have 23 minus 20 is going to give me 3. Okay, then we ask ourselves, okay, how many times can 5 go into 3? 5 cannot go into 3, so 3 is your remainder. So let's go ahead and label all these things that we have here. So we already said 5 was our divisor. 4 would be called our quotient. 23 is called our dividend. And then we have our 3 here, which is our remainder. Can't spell remainder. All right, and then if I took all of this, and this is what it's saying above, and if we did our divisor times our quotient plus our remainder, it should equal our dividend, what we started with. So yeah, if I did 5 times 4 plus 3, that will give me that 23. So yes, it's true, it works, we're good. All right, so we're going to go ahead I'm going to show you guys how to do this with polynomials. So now we're going to go ahead and try x squared minus 4x minus 5 divided by x minus 5. Okay, so same setup. So inside my house is going to be that x squared minus 4x minus 5. Outside of my house is x minus 5. All right, so the way you do this, slightly different, but still the same. You're just going to look at your first term. And you're asking yourself, okay, so how many times can this first term go into this first term? So on and so forth. And then you'll do the math. How many times does this first term go into the next one? Yada, 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 yada. So let's talk about how this works. So I'm asking myself, how or what should I multiply by x to give me an x squared? What do I need to multiply by x to give me an x squared? Or in other words, x squared divided by x. I like thinking about it in this term though. What do I need to multiply this to get that? Hopefully in your heads you guys are all going x. You're going to align it here because this is the x spot. This is the x squared spot, this is the x spot, this is the constant spot. All right, so now we multiply back just like before. So we're going to do x times x and then x times -5, multiplying it back. So x times x is x squared. X times -5, -5x. Here's where we make the mistake. We are subtracting this. So you need to make sure you switch both signs. I highly recommend using a different color to do this, just so it's easy to see if you do make a mistake. Oh, I forgot to switch my sign right there because it's in a different color. All right, and now we just do the math. So x squared minus x squared gives me 0. Don't need to write that. -4x plus 5x gives me an x. Bring down the next one, -5. So now I'm going to ask myself, okay, how many times does x go into x? Or what do I need to multiply x by to get an x? Again, hopefully we're thinking +1. So then we have a +1. Multiply it back. So we're going to get 1 times x gives me an x. 1 times -5 gives me a -5. We are subtracting, so you need to switch both signs. And then we add these. X minus x is 0. -5 plus 5 is 0. So this is your remainder of 0. Okay, when I have a remainder of 0, then that means x minus 5 and x plus 1 are factors of my original x squared minus 4x minus 5. Okay, so those would be factors, which you guys should know, right? What multiplies to give me -5, adds to give me -4, that would be -5, +1. So yes, those are factors. Okay, then, so that's long division. Then we're going to have something called synthetic division. I'm actually going to come back to synthetic division. We'll come back to this page. I'll give you an example. Just because we're going to do long division first, and then I'll show you synthetic division. And then this is the remainder theorem. So it says if you divide a polynomial p of x of the degree n is greater than 1 by x minus a, then the remainder is p of a. We'll talk about that a little bit further as well, so because it's just confusing, obviously, when we read this math stuff. All right, so here's our first example. We're going to divide this. We're going to just do long division again, talk about it, all that good stuff. So inside the house, 496. Outside the house, 16. 16 can't go into 4, but 16 can go into 49. 3 times, multiply back, 3 times 16 gives me 48. Change your color, you are subtracting this. So 49 minus 48 is 1. Bring down the next number, 16. 16 goes into 16 one time. 1 times 16 is 16. Switch your color, subtracting it, and we get 0. So again, when I get this remainder of 0, that means, remember these 3 dots means therefore. We use this in math a lot, or in conclusion. 16 and 31 are factors of 496 because there's no remainder. So that means they're perfect factors. All right, next one, we're going to go ahead and divide. So inside the house, 4x squared plus 9x plus 6 divided by this x plus 6. Okay, again, so we're just asking ourselves, how do I get this to look like that? So what do I need to multiply x by to get it to be a 4x squared? So I would need a 4, and I would need another x, so I need 4x. You align it here because it needs to align over the 9x, same degree, so we put that 4x. Okay, then we're going to multiply it back. We're going to do 4x times x, and then we'll do 4x times 6. So 4x times x is 4x squared. 4x times 6 would give me positive 24x. Okay, we are subtracting this. You need to switch both signs. Do not forget this. This is where you will make your mistake. 4x squared minus 4x squared, 0, and then 9x minus 24x, that's a negative 15x. Bring down the next one, plus 6. All right, so now how I need x to go into negative 15x. So I need these to look identical. So I need to multiply this x by negative 15. So negative 15. multiply it back. So I get negative 15x, and then we'll get negative 15 times 6 will give me negative 90. Again, be careful, switch your signs. This is a plus, and now that's a plus as well. So negative 15x plus 15x, that's gone. And then we have 90 plus 6, or 6 plus 90, which gives me 96. This is my remainder. So how we write our final answer to this is we write this top piece, and then you must add the remainder. But the remainder is being divided by this x plus 6. So that's how we have to do it. So we're going to get 4x minus 15 plus 96, but that 96 still needs to be divided by that x plus 6. So this is how you would correctly write your answer, like so. There we go. And that would be my answer. So pay attention to how we write that remainder. You do not just do plus 96. That's incorrect. All right, let's go next page. All right, so now it says, use polynomial long division to divide this. What is the quotient and the remainder? This is going to be a great time. Go ahead, pause the video, and try doing this long division on your own and see if you're able to get it. All right, so again, inside my box, whoa, we're going to have this 3x squared minus 29x plus 56. I do want to point out, we haven't had it happen yet, but I do want to point out you do have to put placeholders in here. Okay, so if it had gone like 3x cubed minus 29x plus 56, you would have to put a placeholder in there for that x squared position. So you'd put plus 0x squared, just so you keep all of the correct spacing. And then we're dividing by x minus 7. That is not a 9. All right, there we are. Okay, so again, I need this x to look like a 3x squared, so I need a 3x. Multiply it back, so I'm going to get 3x squared minus 21x. Flip your signs, don't forget this step. Okay, so then we'll have negative 8x plus 56. So I need x to look like negative 8x, so I need a negative 8. Multiply that back. When I multiply that back, I'll get negative 8x plus 56. Okay, change your signs, don't forget it. And these are both going to eliminate, so I have a remainder of 0. So what does it mean to have a remainder of 0? That means 3x minus 8 and x minus 7 are both factors of 3x squared minus 29x plus 56. So the answer to this would just be 3x minus 8, no remainder. So I'll write that over here too. So our quotient is that 3x minus 8. Our remainder is 0, meaning that these are both factors of 3x squared minus 29x plus 56. All right, so now we want to know, is x minus 2 a factor of x cubed minus 9? Okay, this is that really important thing I was just kind of talking about above. I go from x cubed to a constant. I have a lot of missing terms. So x cubed minus 9 has missing terms. So you must put in placeholders. Our placeholders obviously are 0. All right, so when we write this out, we're going to have x cubed plus 0x squared plus 0x minus 9. So I put those placeholders in there for every term. Okay, and we want to divide this by this x minus 2. Remember, if the remainder is 0, then it's a factor. If the remainder is not 0, it's not a factor. All right, so we want to get, we want to get this x to be an x cubed. So I need 2 more x's, so we need an x squared. Okay, multiply it back. When I multiply it back, I'll get x cubed minus 2x squared. Don't forget to switch your signs. So this becomes a minus, this one becomes a plus. Add those together, we're going to get that 2x squared. Bring down the next one, plus 0x. All right, so now I need x to become a 2x squared, so I need 2 more x's, or a 2x, not 2 more x's. So we're going to have plus 2x. Multiply that, so we're going to have 2x times x is going to give me that 2x squared. 2x times negative 2 is going to give me a negative 4x. Switch your signs, because we are subtracting it. So now we have a 4x. Bring down that negative 9. Okay, so now I need x to be 4x, so I need a positive 4. Multiply that back, I'm going to get a 4x, and that's going to give me a minus 8. Don't forget to switch your signs, so I'm going to end up with a negative 1. This is my remainder. So is this a factor? No, because remainder is negative 1. So x minus 2 is not a factor. Perfect. Let's go ahead, pause the video, give example 5 a try. Okay, so for this one, it says, is x minus 4 a factor of 5x squared minus 17x minus 12? If so, write p of x as the product of the two factors. All right, same thing. So we're going to have 5x squared minus 17x minus 12. Okay, and then we're dividing by an x minus 4. So I need x to become this 5x squared, so I need a 5 and an x. So we're going to have 5x. Multiply that back. I'm going to get 5x squared minus 20x. Change your signs. This becomes a minus. This becomes a plus. So now we're going to have 3x. Bring down the next thing, minus 12. Okay, now I need x to become a 3x. To get x to become a 3x, we need a 3. Positive 3, multiply it back, so I'll get a 3x minus 12. Change your signs. And then we're going to have a remainder of 0. So since we have a remainder of 0, yes, it's a factor. All right, so now we want to write it as the product of two factors. So p of x is x minus 4 times 5x plus 3. Okay, so that's long division. Now I'm going to teach you something called synthetic division. Synthetic division is going to be our main go-to. Synthetic division is what we actually really like. It's quick, it's easy, and it's going to be really useful for when we start doing like the next section. It's going to be extremely helpful, extremely useful because it's quick. So, go down. Okay, so the procedure for synthetic division, you're going to write the polynomial in standard form, include zeros for missing powers of x. Super important. We need to include zeros for missing powers. So those placeholders again. Okay, then we're going to omit all variables and exponents. So that means we're just going to put the coefficients on each term. So we're going to get rid of the x's, or the y's, or whatever the variable is, and then we're going to get rid of all the exponents as well. For the divisor, you're going to reverse the sign and use a. Sounds confusing. What this means is you're going to solve for x. So like we're not going to want x minus 4. We want to have x equals 4. So we want to solve for that x. And then we're going to add. We're going to be adding instead of subtracting throughout. We will be adding together. All right, let's go back to our first page, and I'm going to do an example and explain it here. So our example, we'll do the same one that we did above. We'll do that same one, but in synthetic. So we're going to still do that x squared minus 4x minus 5 divided by x minus 5. Okay, the first thing I need you guys to do is we need to solve for x. Solve for x. So we're going to have x minus 5 equals 0, which actually means x equals 5. This is my divisor. This is what I'm dividing by, is 5. Okay, so when you guys set this up, now I'm going to call it an upside down house. So it's going to look like this. It's an upside down house. Okay, you're going to have 2 rows. There's going to be a row here and a row here. Okay, so they'll end up being 2 rows, so you're going to make it a little bigger of a house. In the top row, you're going to take this. First off, make sure it's in standard form. It is. Make sure that if there's a missing variable or a missing term that we put in a 0. But we're just going to take the coefficients on each one of these and write those out. So the coefficient on the x squared is a 1. The coefficient on the second one is -4, and the coefficient on the third one is -5. So that's what you guys are going to write out. Okay, the first one, and then we're dividing by that 5, the divisor of 5. Okay, the first one you will always bring down. Whatever it is, you just bring it straight down. So that's 1. Okay, and now we're just multiply, add, multiply, add, multiply, add. So you're going to do 1 times 5. Whatever number that is, which is 5, we're going to put a 5 right here. So 1 times 5 gives me 5. Now we get to add together. So it's just multiplying, adding, multiplying, adding, multiplying, adding. So -4 plus 5 will give us 1. You're going to do it again. 1 times 5 is 5. Put it in the next spot. Add these 2 together. Add together, which is going to give me 0. This last one will always be your remainder. Okay, so look at above. Let's see what we have above. So it was x plus 1. Well, that's technically what this is. This is x plus 1. I know this is x plus 1 because this coefficient's 1, this coefficient's 1. And then your answer will always go 1 degree down because you're dividing by 1x. So now instead of an x squared, you would have just x. If you started with a cubic, okay, let's say you started with a cubic, then this final answer would start with an x squared, x, constant remainder, like so on and so forth. So what this represents right here, 1 degree less than what I started with. I started with squared, so it's 1 degree less. So this is just x plus 1. X plus 1. All right, so let's go ahead and now go to our third page, and we're going to attempt this, and we're going to do it. So we're going to divide x cubed minus 57x plus 56. First thing I notice on this guy is we're missing a x squared, so there's really a 0x squared in there. Okay, next thing is we need to solve for x. So this gives me x equals 7. So you are dividing by 7, not -7. We're dividing by that 7. All right, make your upside down house. Top row is just the coefficients on this guy. Okay, so in front of the x cubed is a 1. In front of the x squared is a 0. In front of the x is a -57. And in front of the constant is 56. We are dividing by 7. All right, the first one always gets brought down. The first one always gets brought down. So we have 1. And then remember, it's going to be a multiply, add, multiply, add, multiply, add. So now we're going to do 1 times 7 gives me 7. Add those together. 0 plus 7 is 7. 7 times 7 is 49. Negative 57 plus 49 is negative 8. Negative 8 times 7 is negative 56. Negative 56 minus 56 is 0. Last one is always your remainder. Put it in a box. Okay, so what this represents, okay, so again, we're always going to start 1 degree less, which makes sense. There's 3 terms here. So it has to start with an x squared, an x, and then a constant. Okay, we know we're going to start with an x squared because this was a cubic function. It's always going to be 1 less because we're dividing out a linear function, 1x. So now it goes x squared. This will be with your x, and that will be your constant. So this represents x squared plus 7x minus 8 with a remainder of 0. So my quotient is that x squared plus 7x minus 8, and my remainder is 0. All right, perfect. Hopefully, like, we're going to practice, we're going to get the hang of this, but this is 5 bajillion times easier than doing long division, and it's faster. And you're going to thank me later when we do the next section. Okay, so this next guy says, if the polynomial x cubed plus 6x squared plus 11x plus 6 expresses the volume in cubic inches of a box with the width is x plus 1 inches, what are the dimensions of the box? Okay, so we're going to divide out that x plus 1 because we know x plus 1 is a factor. Because we know x plus 1 times 2 other factors gives me the volume of this box. So, dividing it out synthetically because that's way fast. Okay, we have a 1, a 6, an 11, a 6. We are dividing by -1 because you must solve for x. So when I solve for x, I get -1. First one, always brought down every single time. Multiply together. 1 times -1 is -1. 6 minus 1 is 5. 5 times -5 is 5 times -1 is -5. 11 minus 5 is 6. 6 times -1 is -6 and 0. Okay, it should have a remainder of 0 because it tells us that that is a factor of it. Okay, so now let's see what we have left. Now we have a quadratic left. So this represents x squared plus 5x plus 6 equals 0. We know how to solve quadratics, right? So you have the options of factoring, completing the square, quadratic formula. Always check if factoring works. So there's something that multiplies to 6, adds to give me positive 5, 2, and 3. So this guy is going to factor to x plus 2 and x plus 3. So this would be our length and our width. Or no, I already gave us width. So this would be our length and our height. Doesn't matter which one's which, I don't really know. So we know x plus 1 inches is our width. Okay, we know x plus 3, we'll say that's the length. And then we would know x plus 2 is our height. If we switch those, doesn't matter. Okay, we know this because if I multiplied all 3 of those factors back together, you would get that x cubed plus 6x squared plus 11x plus 6. All right, so this one is this is going to talk about the remainder theorem, which was on that first page. This is the remainder theorem, which I think is cool, personally. Okay, so it says find p of -4. Remember, this just means that your x value is -4. So it's saying in function p, plug in -4. Okay, personally, not a fan. I really don't want to do -4, especially because you're not allowed to use calculators, right? I don't want to do -4 to the 5th power. Don't want to do that. -3 times -4 to the 4th power. -28 times -4 to the 3rd power, plus 5 times -4 plus 20. That would be really, really difficult and a lot of huge numbers, and it's just not fun. Okay, so what we can do instead is we can use this synthetic division. We can divide by that x value of -4. Whatever the remainder is what your answer would be if you plugged in that number. So much easier, so much faster than actually plugging in that number. And then you guys can always double check me by plugging in the number on a calculator and seeing if that's true. So we're going to do synthetic division. Okay, in front of the 5th power, we have a 1. In front of the 4th power, we have -3. In front of the 3rd power, we have 28. In front of the 2nd power, we have a 0. Don't forget it. 1st power, 5. Constant, 20. All right, we're going to divide by this -4. First one, we always bring down. Okay, and then it's multiply, add, multiply, add, multiply, add. So we do 1 times -4. 1 times -4 gives me that -4. Add those two numbers together. -3 plus -4 is -7. -7 times -4 is positive 28. Add those together, I get 0. Keep going. 0 times -4 is 0. 0 plus 0 is 0. Keep going. 0 times -4 is 0. 5 plus 0 is 5. 5 times -4 is -20. 0. The last number always is your remainder. So first things first is -4 is actually a 0 of this function. But if I plugged in -4 into that function, we'd get 0 as the answer. So p of -4 is 0. So, like I just said, also, that means x equals -4 is a 0 of p of x. All right, and then last one, use the factor theorem to determine if x minus 3 is a factor of x to the 4th minus 81. All right, same old. So list it out. I have a 1. In front of the 3, I have 0. In front of x squared, I have a 0. In front of the x, I have a 0. Constant, -81. Okay, we are x equals 3, so we're dividing by 3. First one always gets brought down. 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 is 9. 9 plus 0 is 9. 9 times 3 is 27. 27 plus 0 is 27. 27 times 3 is positive 81, which gives me a remainder of 0. So since there's a remainder of 0, yes, x minus 3 is a factor of x to the 4th minus 81 because 0 remainder. All right, and that is going to conclude dividing polynomials. I hope you guys really enjoyed that synthetic division. For me, which sounds dumb, I think it's fun and easy and quick to do. So hopefully you guys enjoyed. Have a great day.